In this video, we are going to learn how to graph a tangent function, starting with this one. Now, normally what I would recommend that you do is, as far as drawing the graph, you will start off with drawing a horizontal line, and then you're going to put a bunch of marks on it, at least 8. And then we sort of go from there. Now, when we get to the point of graphing, what I'm going to do is I'm going to cheat and cut and paste an electronic number line. So my cheating will look like this, but you get the idea. Do your best to make yourself one of these when it's time for the sketch. Now, let's fill in some of this required information. Similar to the cosine and sine functions, the general form of the tangent function looks like this, where we have the familiar a, b, h, and k. And a lot of these function in a similar way as they did for sine and cosine. Especially the h being the phase shift and the k being a vertical shift. Okay, so one thing that we used to do is we would start with the period. Now, I'm not seeing period on this list, but we kind of need the period, so I'm going to go ahead and just mention the period now anyway. So, period. I'm going to add it to the list. All right, we definitely need to know what the period is. The period is always going to be the normal period divided by b. Now, when we were doing cosine and sine, we would do 2 pi over b. But the normal period for tangent is just pi. So instead of doing 2 pi over b, the period for tangent will be pi over b. Okay, now, in this problem, the a value is 1. Okay, there's no amplitude anyway, but the a value is 1. The b value would be right here if there was one. All right, so the b value is 1. So that means that the period is just going to be pi. All right, the standard period for a tangent function. Notice that this 3 is not a phase shift. It is not in parentheses, so it's really like we're dealing with this. This 3 is outside of the function. This is going to be a vertical translation. Okay, this is a k value. So vertical translation of up 3. There is no phase shift, none. All right, because there's nothing inside of the parentheses like this. So there's no phase shift. Okay, reflection. There's no negative sign in the front or even on the inside, so there is no reflection. So we can just go ahead and say none. We can say no on that. Okay, I say we go ahead and start doing the graph, and then we'll look back for vertical asymptotes later. Alright, remember that the standard cosine function, if there's no phase shift, it starts at 0. And so there's no phase shift, so I say we put 0 right in the middle of our graph, knowing that the tangent is going to start from here. So we're going to have one point right here, the tangent's going to start there. I'm going to let each one of these marks represent 1/4 of a period, 1/4 period. So if I go out 1, 2, 3, 4, this should be a full period. Okay, which in this case the period is pi. And tangent begins and ends on the x-axis. So one full period is going to start and end at 0 and then at pi. And halfway in between, there's going to be a vertical asymptote. Okay, and I think I will cheat and draw my vertical asymptote using my technology. All right, so, but I need, I don't think it's working. serves me right for cheating. Let me try this again. Alright, so I'm going to put a vertical asymptote down here, and we want to show a vertical asymptote always as a dotted line. So there's my vertical asymptote. Now the tangent function is always increasing. So starting from this first point that we have, it should curve and as it increases toward the asymptote. So it should be like that. And then it will pick up on the other side of the asymptote and curve its way in towards the other x-intercept like this. So this is actually one period of the tangent function right here. Now I want you to draw at least 2 periods of the tangent function. So I'm just going to draw the mirror image of this on the other side. Okay, so 4 spaces to the left, all right, 4 quarters of a period to the left should be another x-intercept. So 1, 2, 3, 4, there should be another x-intercept here, and right in between should be another vertical asymptote. Now I'm going to see if I can again cheat a little bit by cutting and pasting the asymptote that I already had. Okay, and let's do that same behavior again. Remember, the tangent function is always increasing. From left to right, it's always rising. So from this x-intercept, it should be rising toward the asymptote like this. And then it picks up on the other side of the asymptote, and again it is rising as it curves in toward the x-intercept. So this is what 2 full periods of the tangent function will look like, and this is what I want you to graph. Now it's very important, the labeling of the x-axis, and I haven't even drawn the y-axis yet, so I still need to do that. Okay, obviously over here I've got negative pi, but every single one of these marks, these quarter periods, need to be labeled. And so look, we have one period was pi, so we know this is 1/4 of that, so this is going to be pi over 4. And what I like to do is count. Alright, I take that first quarter of a period and I use it as a counter. So this is 1 pi over 4. This would be 2 pi over 4, which of course would be pi over 2. Alright, I mean it's also halfway in between. But this would be 3 pi over 4. And this would have been 4 pi over 4. And so this will be the same in the negative direction, will just be the reflections of these. So this will be negative pi over 4. And this will be negative pi over 2. And this will be negative 3 pi over 4. Alright, that is very important. Every one of these marks needs to be labeled on the x-axis. Now we also need a y-axis, which of course will go at 0. So let me just take a moment and draw that in. Okay, there's my y-axis. Now I'm going to put in a couple additional points just to make a point. Haha, see what I did there? The a value. All right, let's just slide over and take a quick look. If I can make this go away. Okay, our a value is 1. Now, for sine and cosine, that was the amplitude. All right, that served as the high point and the low point. Now, for a tangent function, there is no amplitude because the tangent function goes up forever and down forever. So there's no amplitude. However, that A value of 1 still serves a purpose. And that purpose is, hold on, it is the stretch value, and it's going to occur halfway in between the x-intercept and the asymptote. So let's start over here. Here's the x-intercept, here's the asymptote, here's the point that's halfway in between. That point should occur at the A value, okay, which was 1. Now similarly, right here, halfway between the asymptote and the intercept, I have a point right here. All right, that should occur at -1. Okay, and that's going to repeat for all periods of the function. So again, here I am halfway in between the asymptote and the intercept. So this point right here should be at -1. Here I am halfway between the asymptote and the intercept. This point should be at +1. So in addition to labeling all of these marks on the x-axis, we also need to label the stretch value on the y-axis. All right, and go ahead and mark those additional points as well. All right, I think that's it for problem number 1. Oh yeah, vertical asymptotes. We're supposed to list out the vertical asymptotes. Now we have 2 of them showing right here. All right, we have a vertical asymptote at -pi/2 and +pi/2. So let's write that down. A vertical asymptote, or any vertical line, is always x equals a number. So x equals -pi/2 and x equals +pi/2. Okay, now we're going to have more vertical asymptotes repeating every period. Okay, so every time I add pi, since pi is the period, I'm going to get another asymptote. So if you really wanted an equation for all of the asymptotes, here's what you could say. I think I'll use purple. An equation for all of the vertical asymptotes. Pick one vertical asymptote, pi/2, and if you add the period and give it a multiplier, n. So if I add pi n, that's going to give you all of the asymptotes. Now I should say x equals in front of this. Can I just squeeze it in? X equals. And so that would be an equation for all of the asymptotes where n is an integer. Now getting back to the graph, if I wanted to see visually where the next vertical asymptote would be, remember that the period is pi, but we have divided the number line up into fourths, quarter periods. So every 4 marks is a period on this scale. So that's why, see how there are 4 marks, 4 spaces between the left asymptote and the right asymptote. So it's like 1, 2, 3, 4, and I have another asymptote. So if I were to count over 1, 2, 3, 4, there should be an asymptote again right here. Alright, so sometimes you can use that to help you if you're having trouble. If you need more asymptotes for a list that you're being asked for, you just graph more and then see where they fall. So you know there's going to be another asymptote there. Now what is that called? Okay, if we keep counting, remember this is 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4, 5 pi/4, and this would be 6 pi/4, which reduces to 3 pi/2. So we have another asymptote at 3 pi/2. So if you needed to list off 3 asymptotes, you could say x equals 3 pi over 2. Yeah, so the direction said, please give us the equations for 3 vertical asymptotes. So that's why I went ahead and did it that way. All right, now that really will do it for problem number 1. And let's go ahead and do one more problem. I know this video is going to be a little bit long, but let's go ahead and squeeze in problem number 2. I'm going to do this one faster. All right, problem number 2, we have y equals negative tangent x. So this is the parent function, except for this negative sign in front is going to be a reflection over the x-axis. So this is going to be a reflection. So we'll definitely say yes on that. I'm going to come back to the vertical asymptotes. As far as phase shift, there won't be any. All right, the phase shift will happen when you have like x minus pi over 2 or something like that. That would be a phase shift. We don't have that happening. Okay, it's nothing with the parentheses. There's also no vertical translation. There's nothing being added or subtracted on the end. So we'll say none to that as well. Okay. Now, let's talk about the period, which is not listed here, but it is something that we need. The period. The standard period for a tangent function is pi. Since there is no b value changing things, there's no, I'm pointing to the wrong place. Since there's no b value, the period is just going to be pi. Okay, so that's going to be important. Now we have memorized that for a tangent function, unless there's a phase shift, it starts at 0. So somewhere here in the middle of my graph, I'm going to go ahead and put 0. And I'm going to understand that tangent starts right there. Okay, so I'm going to go ahead and draw a dot. Now, so since the period of tangent is pi, okay, then if I go pi to the right, it should repeat. So I'm going to have another value on the x-axis. Now, every one of these marks, I'm going to use them as 1/4 of the period. Right? I'm always doing 1/4 of the period. So that means if I do 4 of them, that should be a full period. So if I go out 1, 2, 3, 4, then this should be a full period. This should be pi. Now, if I go to the left, we want to draw 2 periods of the tangent function. So if I go to the left 4, 1, 2, 3, 4, then again, the pattern should repeat, so I should have another x-intercept. All right, starting from 0, every time I go 4 places, I should have another x-intercept. Okay, now let's go ahead and label what we have so far. Remember, the period is pi, so this should definitely be pi, and this should be negative pi. I'll come back to the labeling in a minute. So x-intercepts, for the tangent function, you have x-intercepts at 0 and at the end of the period. Now, halfway in between, there is a vertical asymptote. Okay, and now I'm going to try to borrow my vertical asymptote from my last problem. And bring it down. Cut and paste. Got to recycle, reduce, reuse, recycle, people. All right, so if I go halfway in between, there should be a vertical asymptote. Similarly, on the left-hand side, I'm having trouble grabbing it. If I go halfway in between, again, there should be a vertical asymptote. All right, so here's my tangent function beginning to take shape. Now, starting from the x-intercept, think about the tangent function and the fact that it is always rising. The tangent function is always increasing. So from this x-intercept, the tangent function will increase as it curves towards this asymptote, like this. Okay, now if I pick up on the other side of the vertical asymptote, so it's going to start off down low, but it's increasing. Tangent is always increasing, and it's going to curve in towards that x-intercept again. And it's going to do the same thing on the left. So if I start from this x-intercept, tangent is always increasing. So it's going to be increasing as it approaches that asymptote. All right, got a little crooked there, but nobody's perfect. And it's going to pick up down low on the other side of the vertical asymptote, and it's going to always be increasing, but it's going to curve its way in towards that x-intercept. Okay, so here's what 2 periods of the tangent function will look like. All right, this is one period on the right-hand side, and this is one period on the left-hand side. Now, this is what it would look like if it was not a reflection over the x-axis. So just get a good look at it, because what we need to do is we need to take each of these and turn them upside down. Okay, so this is what it would look like if there were no reflection over the x-axis. Now, because there is a reflection, instead of the tangent function always increasing, because it's upside down, the tangent function will always be decreasing. Okay, so now everything is upside down. So this tangent function is going to be decreasing now. So it's going to be decreasing as it approaches the asymptote, like this. And it's going to be decreasing as it approaches the x-intercept, like this. All right, and it will be decreasing on the other side as it approaches the x-intercept. And from this x-intercept, it will be decreasing as it approaches this asymptote. So this is what the function will look like after a reflection over the x-axis. Everything is upside down. All right, let's finish labeling the x-axis, and let's get the y-axis in here. Every one of these marks is 1/4 of the period. So, you know what, I feel like I should change colors. So this will be pi over 4, all right, 1/4 of the period. And this would be 2 pi over 4, which is just pi over 2. And this would be 3 pi over 4. And over here we have the mirror image. So this should be negative pi over 4, and negative pi over 2, and negative 3 pi over 4. All right, now let's get the y-axis in there. All right, here's the y-axis, and there is something that needs to be labeled on the y-axis. The a value. All right, now the a value is -1. All right, the negative sign was the reflection over the x-axis. Okay, but just looking at the 1 part, you know, the absolute value of -1. Just look at it as 1 for right now. For sine and cosine, that would have been the amplitude. Tangent does not have an amplitude, but that a value of 1 does play a role. And here's what it is. Halfway in between the asymptote and the x-intercept, you should be hitting that a value. So this is the point that's halfway in between the asymptote and the intercept. So this point right here should be at the a value of 1. And again, over here, halfway in between the asymptote and the intercept, this should be at -1. And right here, halfway in between the asymptote and the intercept, this point is at -1. And over here, halfway in between the asymptote and the intercept, this point should be at +1. Okay, so that's important that we label those and include those dots on the graph. And that's it, other than listing out the vertical asymptotes. So we have two vertical asymptotes showing in the picture, one at negative pi over 2 and another at positive pi over 2. We're supposed to list three of them. So we have x equals negative pi over 2 and x equals positive pi over 2. Okay, but we would have another one if we kept going. All right, we did this on the last problem. These are odd values. This is like 1 pi over 2, 3 pi over 2. If I kept going, it'd be 5 pi over 2, 7 pi over 2, 9 pi over 2. All right, so odd multiples are going to give you the asymptotes. So it's the same thing here. So this is going to be x equals 3 pi over 2. And that's it for problem number 2. And that's plenty enough for this really long video.